Hi and welcome to my channel. In this video we'll explore route-based VPNs in Checkpoint, explaining how they work and why they offer more flexibility than policy-based VPNs. You will learn how to configure VPN tunnels using virtual tunnel interfaces, the VTIs, and dynamic routing protocols like OSPF. So the route-based VPN allows administrators to control VPN traffic using routing tables, making it possible to apply advanced traffic engineering, load balancing, and failover mechanisms. But first, let's try to draw a topology on how we are going to use this. So let's figure this is a gateway, and this is another gateway here. And we can maybe use this as the internet here, and then we can connect this one to the internet and this one. So for example, this one is the, call this one, and this is the central office, and type here central office, and this is the other gateway, which is branch office. Here, for example, branch office, like this, and we can here, because this is a lab, this IP will be a private IP, but in production this IP is a public IP. So let's get 10.145 here, this 6 here. We'll build our VTIs. So let's draw a line is just like directly connected gateways. So we will create two VTIs or two interfaces. This interface here will get this IP 210, and this interface here will get this IP 10. So this is a VTI interface, and this is here a VTI interface. Here these gateways have another interfaces or physical interfaces like this one. So here we have interface of 10.10.10.10, and here we have some kind of server, for example, which has the IP of 10.10.10.3, for example. And here, same, we have kind of server which has the IP of 22.10. So this server here needs to get to this server through the tunnel. So this is the topology that we will be working with. So let's get started here, and we will be back here to check our topology. So first let's enable the VPN blades on both these gateways. Okay. And we click on OK. And we need now to install the policy. So the first thing to do is creating a dummy group or empty group, a group on both VPN domains. If you configure a security gateway for domain-based VPN and route-based VPN, then domain-based VPN takes precedence by default. So to force route-based VPN to take priority, you must create a dummy or empty group and assign it to the VPN domain. And we can do this. So if we double click here and we go to VPN, click this and take link selection. Here we need to choose main address. The main address, it means this IP address here, this one. So we left this as main address. Go to VPN domain. So here we need to define an empty group here. So we check this, user define, click here, and then new group and simple group. Let's call this empty group, this gateway 1, and click OK. Let's choose that and click OK here. Let's do the same with the other. So VPN domain, user define, create new group. So empty group two. Let's make it like this and click OK. So it's very important to have these empty groups defining the VPN domain. So choose them and click OK. So the link, as we said, the link selection here, we need to also make sure that the main address is chosen. So the VPN tunnel is created using the main IP address of the security gateway object that is configured on the general properties, as we said. We need now to configure the VPN community. So it is very important to make these groups and put them on the VPN domain. So let's now create let's install the policy ones here. Install. Let's go to the community. So here we choose VPN communities and we create a new one, a new star community. Here, enhanced, we have, this is new for the R82. We have legacy and enhanced. The enhanced link selection improves interoperability by enabling the configuration of multiple external interfaces for VPN connections. Link selection is a method to define which interface is used for incoming and outgoing VPN traffic, as well as the best possible path for that traffic. But for the sake of this video, let's stick with the legacy. So this is new, as I said, this is new enhancement in the R82. But for the sake of this video, let's stick with the legacy. And the legacy link selection, the administrator can choose which IP addresses are used for the VPN traffic on each security gateway. So here we add our gateways. So here we choose this one as the central office, and we choose this one as the branch office. Now we can choose here, we leave it at to center only, so to split the tunnel. So only we don't need to send all traffic from one gateway to another, but we need only to send what we define in our routes. And we can take maybe here we can disable NAT inside the VPN community. So there are scenarios where enabling NAT within a VPN tunnel is necessary, such as when there are overlapping IP address spaces between the connected networks. In such cases, NAT can be used to translate addresses to avoid conflicts, but that is not our case, so we need to use this disable NAT so we can use some CPU cycles. Let's call this route-based VPN, something like that. Encryption, we leave everything as it is. And click OK here. Let's install the policy. Install. And now we need to create, configure the VTI interfaces on every gateway. And to do that, we need to log into the Gaia portal. So let's try to configure it on the first one. Here. So the use of VPN tunnel interfaces, the VTIs, is based on the idea that setting up a VTI between peer security gateways is similar to connecting them directly. A VPN tunnel interface is a virtual interface on a security gateway that is related to a VPN tunnel and connects to a remote peer. You create a VTI on each security gateway that connects the VTI on a remote VPN peer. Traffic routed from the local security gateway via the VTI is transferred encrypted to the associated peer security gateway. So here we click on network interfaces and we click on add here and we choose VPN tunnel. This is the VTI. Let's call this the GW1 so we know. This VPN tunnel ID should be the same on both gateways. So if we choose, we can choose from 1 to 100. So let's choose, for example, 20. And when we choose 20, this number should be the same on this gateway and on the other gateway. Peer is the name of the other gateway. So this is the 145. So let's look here. This is 145 called GW1. So we need the name of the other one. This one name GW-2 should be the same. Let's go there. 2 like this. And the local IP, so the IP of this interface will be this one, 10, something like that. And the remote address, so the IP address of the VTI on the next gateway will be this one, 210. And we click OK. So now we need to log into the next, this machine here. I can use it to reach that. This one. Let's log in again. So interfaces, we do the same. VPN tunnel. This is the GW2. This is 20. Should be the same. It's very important. And the name of the other gateway. And here we need to do exactly the opposite. So 210. Here we can take this 110 like this, and we click OK. So now we can go back to our smart console here, and we need to grab these interfaces. So get interfaces without topology on this one, click OK. Let's configure it, configure the anti-spoofing. Okay, okay, and okay. Let's do one last check. Don't like this IP address here. What's this? Okay, let's check it there. Edit. Maybe I did something wrong here. Okay, so let's remove this one, delete, and add it again. So this is the 45. Like this. So now it is correct. Let's do another get interfaces. Now it is correct. Now we can. Okay, it is okay. Okay, here. Let's get interfaces on this, on the other gateway. So without topology. And this is okay. Except let's configure the anti-spoofing and click OK, OK, and OK. So let's install the policy once. So now if we look back again here, so now we can, this interface should be able to ping this interface. Now we will try to do that, and the opposite is correct. So let's wait until this policy is installed. Okay, so let's grab PowerShell here and log in to our, for example, log in here. Log. Okay. Let's take a look at our interfaces. So here we have this interface. So show. Okay, let's try to ping 10. So we can see that we can ping. So now we can ping from this here, this interface can ping this interface. So let's try to do it from the other side. Let's grab this one here. Grab it again. Let's try again to the 6 and so ping 22 10, and we have ping. But what if in our case we need this server to get to this server? So I have two servers. So here we can see this server, for example. Can log in here. Try to start a ping. So let's grab PowerShell. Okay, let's check the IP address of this machine. This is the 210. Okay, this is this one. So this one should be able to ping this one. So let's try to do that. So ping 10.10.10.3. Okay, ping 10.10.10.3. And no ping. And why is that? Because this we have this server here and its gateway. So let's put the gateway here. Its gateway is 2222. Let's make it a little bit bigger, maybe something like that. So this server is sending to its gateway, but here this gateway does not know anything about this server. So there is no route in its routing table that says how to send the traffic to this server. So we need a mechanism to enable this gateway to know about this, and that is the OSPF, or routing protocol. So we need to activate OSPF here so that it will publish this network to this gateway, and the opposite is correct. So we need OSPF here to publish this network to this gateway. We can do this with a static route, but in reality, in production, you are not having only one interface here, but you maybe have 100. And with many interfaces, you don't need to use. It will be difficult to have control on of static routes, but a routing protocol is definitely used. So let's start configuring the OSPF on this gateway first. So this is the 145. Now let's start activating. Let's log into our gateway first, and we can start by enabling the area, this command. So allowing OSPF routing to be this area will allow OSPF routing to be active within that area and to exchange routing information with neighbors in the same area. So the next command is the router ID. And this IP address, you can choose anything you want. This is only to, so the command set router ID assigns a unique identifier to the OSPF router, typically an IP address, which is used for OSPF operations like route calculations and neighbor identification. So we can choose 1111, for example. So any IP address here. And we click enter, and now we need to add our VTI to the area. So this command will add this interface to the area. But what we need here, so this interface is already there, and that so this interface can reach the other side, but it is about this interface. So we need to do the same here, but with ETH1. So ETH1 is this interface here. We need to add this interface to the OSPF, so OSPF can publish it to its neighbor here on the other side. And then this interface IP address will be in the routing table here. So let's click enter here. And the next command is this. We need to redistribute. So this command will redistribute any route in this gateway to the OSPF neighbor. So static route, any route will be redistributed or published or shared with the neighbors. And now we need to save the config here. So we are done in this side. So let's go to the other side. Let's log in here. And we will do exactly the same with only small changes. So first we create the area, copy, and we set the router ID, like this, but let's take 6 for this one and reset the interface, the VTI, add it to the OSPF, and the same for the ETH one, like this, and we redistribute all routes to the neighbor, and we save config. So now both these two OSPF should be neighbors. So we can check that by this command show OSPF neighbors. So now we can see that we have this neighbor, this router ID. So you can see it, neighbor ID is the router ID, which is the other one. So now we are here, we can see that this is our neighbor, and it is through this interface. And we can do the same on the other, so to show OSPF neighbors, and we are the same, we have the same. And now, because we have all, so we can show route OSPF. So we can see that OSPF is sharing this route with us from the other side. So it's this here is coming through this and through the VTI. And the same is true if we look here, so show route OSPF, we can see that we are getting a route from the other side using OSPF, and O here, O is OSPF, as you can see. So now let's try to ping. Let's go there, log in. So now let's try to ping, and now we have ping, as you can see. And on the other side we can do the same. Here we need to log in here. Let's log in and try to ping this one, and now we have a ping. So let's take a look at the logs. So now let's check the logs here, and we can check first this one. So let's do a new ping here, and we can go back there and try to see VPN pings, so we can see here directly. And the same is true if we check the other side, this one, we will see some VPN traffic, this one. But how to generate a real traffic? So let's go to this server here and create a shared folder. Let's create a folder here, shared. Let's share this folder with anyone. Let's go there, share, permissions, everyone, apply, okay, apply, okay, okay. And let's go to the side there and try to let's go to this, and so now let's from this server here try to open that folder, shared folder, and see and generate some traffic. So now we are opening this, so let's get some files here and try to paste them. So now we are generating traffic. So let's go to the again here and let's look at some VPN traffic, and we can see here much VPN traffic, and it is Microsoft DS. So let's look at the other side again. This one should be the same, Microsoft DS here. You can see we have some traffic, Very interesting. Okay. Here, so now we can look this side. We have got these here shared. So this video is done here. So thank you for watching and see you in the next video.